Hello everyone, my name is Draconicrose and welcome back to While True Do Learn. Today we are going to continue on with the story and predictions of winnings in a casino. Hey there, you know, I'm a big gambler. I'm going to Vegas next week and hopefully I'll make some money. Did I say some? I meant to say huge money. I need you to write some code, or whatever you do there, and predict all the ways I will win in a roulette. If you do everything right, 5% of my score is yours. Please find some related data enclosed. And we shall proceed. So this is a pretty easy looking one. We just need the reds, mostly down here, but if we 50% it should be okay. So here is one of my solutions. It is actually a silver gold one, but you will see when I do the test run that the balancer divides all the inputs. It goes to a pre-trained genetic, and off the other side the thing here is that it takes quite a few more seconds than the gold time wants. One more second. So yeah, if I had faster nodes, I don't think it would. The pre-trained genetic is just, you know, a genetic solver, just dividing all of them. And for some reason, it is faster than if I use this, I think. So I don't know. I'm going to go with this solution. You could easily replace these two with genetic solvers. So onwards, upwards and onwards. That is what I'm. So we will release, and there we go. You get a good chunk of money, and we move on to UFO Recognition. Hey, please help me. Aliens want to kidnap me. I'm building a large station to keep an eye on the sky around my house, but the image recognition system does not work. I know that all the Martian ships have round shapes, and those from Venus are triangular. Please divide them into two classes. I must be prepared. Yeah, I think they got kidnapped. So now we get a new node, the decision tree for shape. This node compares socket shapes with element's color. If an element color is equal to only one socket's color, the element moves to that socket. If an element shape satisfies both conditions or none of them, it moves to a random socket. In the real world, decision tree can use more complex dependencies. For example, each question might be a sift node, which is trying to find an eye, a mouth, tail, or wheel. As a result, the decision tree may detect a human, a mouse, or a car on an image. So we shall continue and use the decision tree. In this case, we only want simple shapes, so this one is basically a tutorial. And we will let it do its thing. See, it doesn't even have other levels. It's pretty slow. We'll release that with the new node used and accept our money. And continuing on. Photo parsing instrument for a construction company. Good morning. We work for a construction company. We need to ensure that the windows we want to install are designed accurately. Please create a program for smartphones that could proof check our designs for potential mistakes. And we proceed with another decision tree of shape. I think, yeah, in this case it just wants us to delete the other one, so yeah, it only wants 10, and we have 12 of those. So yeah, triangles is good. I think that should work. So getting all triangles going down here. All squares are going up here, yeah. It's pretty good so far. We didn't get to see all of it, but good accuracy, so yes, that's what we wanted from that. Okay, 1 minute survey to get a hip theme for the main menu. I would love to, but I'll do that later. We'll continue by optimizing the roadway traffic. Hello! We are preparing the road surface in our city every day. Not surprisingly, it generates some problems with the road traffic. We ask you to write a pathfinding system. Thanks. Okay. So Dip News says math data representation, main axis of the fish. As a little 3D fish, I assume, in an axis? Or maybe not 3D, it just looks 3D because of the second axis in here. In many cases, data is represented by obvious parameters: gender, age, salary, or distance to the nearest fridge in meters. This kind of data is suitable for any human being. Perhaps you're already familiar with the concept of correlation, which is also a fairly good parameter for analysis. People skilled in using simple mathematical dependencies are called analysts. Truly hardcore mathematicians go even deeper and describe data with distributions or even, oh boy, conditional probability distributions. Those principles cannot be explained without whiteboard and a math degree. This is where machine learning steps in, and sometimes algorithms are capable of finding dependencies that couldn't be even imagined by the brightest human mathematicians. I hope that made more sense to you than it did to me. So in this case, we want to get the shapes where they're supposed to be in 7 nodes. Well, I think I have a solution, so I'll be back when I have it on the board. So my current solution is a little slow, so I decided to come over to the store and see what we can get for our hardware. And I think this is what we want. Or do we want nodes work speed? Nodes work speed seems best. Let's take a look. By 10%, so yeah, we could do that. And we still have enough that we can probably do this one as well. I think they are cumulative? Cumulative? That's something like that. I'm going to leave quite a few meow bugs or some, whatever the name. See if that works the way I think it does, because if it does, well, I would need to shave a full 3 seconds off the work. But it did! So this solution was a silver metal solution, now it's a gold metal solution. So there you go. We can release that and continue on for fast data sorting. Good morning, we have a scientific satellite that aggregates data from our geomagnetic researches, but we need to put it down and launch a new one to the orbit. Can you help us extract and process the data from the old satellite? I sure can, but first let's take a look at our private letters, because yeah, we often have just cash on the mails, and if you want to read what's on the cash mails, you're welcome to just pause the video whenever they are open. So there we go, we have those. So we'll head back into Seabay, and it looks like we unlocked a new upgrade. Now, do we want the server cost or processing queue? Well, I think what I want is to buy everything that increases the node's work speed as much as we can, because that is really what's up with us, with our solutions. And once that is done, we will get the processing queues, because those are also important in reducing the work speed of the solution. So what is this? We need to take the red circles and go up, the green squares and the blue triangles, and everything else is trash. Alright, so let me take my hand at this and I'll be back. Alright, we have our solution here in 4 less nodes than the level requires. So first things first, we send our data into an RGB sort, which is one of the tasks we had before. All it does is divide the colors like pretty fast into red, green and blue. So we have our colors already separated and that's the first problem dealt with. Next, each color goes into a tree. This is basically a mega decision tree. So reds go up and we check, is it a circle? If so, let it continue on. Is it a square? If not, it goes to trash. If it's neither, just send it randomly, because if it's not a circle, we don't want it anyway and it can be trashed. But if it is potentially a circle, we want it to continue. Then the second decision tree will eliminate all the triangles. Is it a circle? Then go to the output. If it's not a circle, it can only be a triangle because all squares get eliminated over here. So we trash it because we don't want the red triangles. And you gotta remember that each of these is already color sorted, so only reds will come through here, only greens through here, and only blues through here. The other trees follow the exact same logic, though the starting shape is different. We just want the squares over here, so we select for squares. Everything else, it's hard to see, but it goes to the trash. I'll run it and let you see for yourself how it works. And there we go, we get 100% accuracy and occupancy, and there is our result. We can continue on. We gain a chunk of money, which, before we go into story, means we can buy some new hardware. Nodes work speed? Yes, please. How is the rest of our money? Like that. Let's reduce server costs now, because that means we get to keep more of the final money. And yeah, we'll just go from our data transfer speed, and that's fine. Alright, in our inbox, apparently there's one we didn't read. Oh, it's from the other tree, so let's go ahead and get ourselves a story one. We've reached the end of the epoch, so not enough gold for that, but we do have enough silvers. So let's continue. Okay, we need more cats to collect data. You up for a party? And you're going to film the cat. And other cats with their emotions. A cat emotions database, that's fine, and we're going to read the points on the face. Improved cat emotion recognition. Hooray! Goal, recognize complex emotions, sarcasm and such. And we get another learning task. Animal speech recognition, cat speech recognition, how to. Gotta admit, Dr. Coder was probably right. This genetic algorithm is just too clumsy, especially now when I'm starting to work with speech recognition. Watson vs. Crick says, hey, come on, you haven't even waited for a year. Have some respect towards the natural selection, why don't you? Yeah, they've made a lot of improvements to perceptrons since old man Rosenblatt was around. Now they tend to join multiple perceptrons in the big bad neural networks. Something like that could work for you, but don't forget gradient descent. It's like a life coach for our neurons, helps them on the right track. Maintain accuracy level. In certain tasks with perceptrons, you need to keep the accuracy of your data flow above the required level while the timer is filling. If the accuracy drops, the timer will be reset. The timer is only active in test run. Oh, well, that's interesting. Perceptron shape. In the game, while in training mode, the perceptron reduces the amount of errors trying to predict the color of elements. In the test run, the perceptron only predicts colors. In the real world, unlike Rosenblatt's perceptron, Present-day perceptrons can predict more complex, non-linear dependencies. Most common functions inside perceptrons are tan, hel, and sigmoid. Perceptrons are basic elements of each neural network. So I did work with sigmoid perceptrons. They basically go 0, 1. And yeah, basically something is or isn't. But a group of them actually does do some interesting stuff in the game. Each element in the game has a small error to fix value. This node increases this value. Okay, warning, this node doesn't run in test run. Weird. In the real world, gradient descent is one of the basic algorithms which can train models, not only neural networks. Gradient descent calculates gradient of all objects and steps closer to the target answer for the task. It takes a lot of time. See, even Doofus doesn't like that. So, let me see what they want from me here. So, I'm not entirely sure what I am supposed to do here, but I did run out of time. Maybe I need to train? So let's take a look. Yeah, the perceptron is going to run out of error. There we go. And it should become more accurate. The nodes on the field have reached their minimum margin of error. Hooray! Let's do the test run and see. Okay, we do get the better accuracy, and that is about it. But that is where we are going to have to leave off. I know this one is a bit shorter than usual, but that is the time I have for recording. So if you enjoyed this episode, don't forget to comment, like, subscribe, all that cool YouTube stuff. And if you really enjoyed it, check out my Patreon. Your support is what allows me to keep doing this with some sort of, purpose. So until next time, please remember that here, there be dragons.
Thank you so much to my patrons for making this channel possible. Click the Patreon logo to become one of these fine folk. And if you enjoyed the video, here are some more YouTube things you would like. Don't forget to like this video and subscribe. Have a lovely day, and I'll see you next time.